problems. So that is why today I shall consider that part. The important first point is the mu test. Do you hear me? Hello, students.
Yes, sir.
And the
Yes, sir. Yes.
screen is also visible.
Yes, sir.
Okay. Now I am continuing. The mu mu test is very important for solving so many important problems, and which there are two mu tests for improper integral of first and second kind. First one is if f(x) is an integrable function, and if we integrate the first kind, that is the range is finite, a to b fx dx. Now this converges provided limit of x minus a to the power mu x tends to a plus 0 into fx is equal to L. Remember that if the function is bounded within the range of integration a to b, but at the point a the function is unbounded, so we consider taking the limit at x is equal to a only, and it is always a plus 0. Since a plus 0 is within a to b, that is why we take the limit, right hand limit. This is also called right hand limit. X minus a to the mu fx is equal to L. And a non-zero, L is the non-zero finite number, and if mu lying between 0 to 1, that is, it is a positive proper fraction, then it converges, otherwise diverges. That is, for mu greater than or equal to 1, the mu diverges. So this is the mu test for the second kind, and for the first kind this, that fx be bounded and integrable in the range. This is the first kind, that is, here we take the upper limit is infinite. So we assume that the fx is bounded and integrable in the range a less than equal to x less than equal to capital X, where capital X is a finite number, and we take the limit as x tends to infinity and a greater than 0. If there exists a number mu greater than 1, such that limit of x to the power mu fx x tends to infinity exists and be equal to a non-zero finite number. Non-zero finite, this is very important, non-zero finite number. Then a to infinity fx dx is convergent. If mu is less than or equal to 1, then it is divergent. Now, similarly, if we take minus infinity to a or minus infinity to b, we proceed in the same way, and also both minus infinity to infinity. Then in this case we get two parts, minus infinity to a to b, a to infinity. Now minus infinity to infinity can be split up into two integration as minus infinity to a plus a to plus infinity, and considering the two parts individually, we get the required result. And remember that for mu greater than 1, the integral converges, otherwise divergent. Now you consider, this is very easy problem. This is mu test. Achha. Now here fx is equal to this. Now we take gx, which is obtained from fx by considering the highest power of x in the numerator and the highest power of x in the denominator, that is x square by x to the 4, or 1 by x square, and finding out the limit of fx by gx x tends to infinity. This is of second kind, and therefore this is of first kind, and infinity upper limit is the infinity. Taking the limit as this and x tends to infinity, it will be 1. It is a non-zero finite number. So according to the given statement, these and these have the same nature. But remember that gx, it is a known function. Gx is equal to 1 to infinity dx by x to the mu, is convergent for mu greater than 1. It can be easily verified. Just simply plain integration. Taking the integration and putting the limit as 1 to infinity, and we see that the answer will be finite. So, for provided mu greater than 1. So, it is easily proved that for mu greater than 1, the series, this integral takes the finite value. So, it is convergent. So, therefore, for mu greater than 1, since gx is convergent, fx is also convergent. These and these have the same nature. This is the statement of the theorem. Another method. Then actual answer is pi plus 2 by 8. So it is convergent. Apply mu test for this. I is equal to this. Here we take mu is equal to 2 because here mu is equal to the highest power of the numerator and the highest power of the denominator minus. So 3 minus 1 is equal to 2. Actually, we consider the function in this way, 1 plus x whole cube divided by x. So highest power of x and of the denominator and highest power of the x. Difference between this. It is mu is equal to highest power of x in the denominator is 3 minus highest power of x is 1 in the numerator. So 3 minus 1 is equal to 2. So we take mu 2 and taking the limit, it will be 1 in non-zero finite number. Since 2 is greater than 1, so I is convergent. Similarly, this function. The important problem is this. And I hope you have already tried for another problem. Minus 1 to 1 dx by x cube or x to the 5. Now this problem is very important, and this problem has two answers. One is the general sense and another is the Cauchy principal value sense. So this problem is important in the examination also. So I am again try to understand so that you may easily understand. For this problem, minus 1 to 1 dx by x cube or minus 1 to 1 dx by x cube, the power of x must be 3, odd number. Here, this is an improper integration of the second kind, since the range is finite. Although the function 1 by x has infinite discontinuity at x is equal to 0, which is the intermediate point of minus 1 to 1. 0. Now if x is this, we're taking simply dividing this into two parts, minus 1 to 0, 0 to 1, and writing this and taking the limit this. In this case, you write 0 minus epsilon. Since 0 minus epsilon lying between minus 1 to 0, and 0 plus epsilon dash, it is always lying between 0 to 1. So write in this way. Epsilon dash may be equal or unequal. In the general sense, they are equal, but in the Cauchy principal value sense, they are equal. So we get this, taking the, just integrating, taking the limit, you will get the value this. Now we see that epsilon dash two independent numbers যদি হয়, if epsilon dash are two independent numbers, then it will be either 3 epsilon dash or 2 epsilon dash. So we get different answer. So the answer is not unique, and that is why the integral does not converge in the general value sense. That is, when epsilon not equal to epsilon dash. But if we consider epsilon is equal to epsilon dash, then this is equal to log 1 is equal to 0. So it is a finite value. Therefore, the general value sense integral does not exist or converge, and the principal value exists. So this is the interesting point of this problem, and also new one. This is very good relation. Just gamma n plus half is equal to gamma this. This is very also important relation. And writing this is equal to this is equal to this one. And we write now, we know that gamma n plus 1 is equal to n gamma n. So this is n, or m, suppose m plus 1, m gamma m. Similarly, proceeding in this way, continuing in this way, we get another term and so on. Repeating this and putting this and simplifying, you will get this value. Now, remember that multiplying numerator and denominator by all the even number. In the numerator, all the odd number. 2n minus 1, 2n minus 3, 2n minus 5, 5, 3, 1 odd number. So dividing all the even numbers, that is 2n, 2n minus 2, 2n minus 4, 4 into 2. And simplifying, you will get this value. In the numerator, taking 2 common and cancelling, you will get this value. So this is the very important result. And in another form, there is also another form, this. And this is also very important, relation between or gamma function. Remaining part is very easy, just. And also there is another good relation, it is this. Gamma m, gamma 1 minus m is equal to pi cosec m pi. You may commit to memory this relation, and applying this relation, it is possible to solve so many problems of this type. 7.2. 7.2 is this type, gamma 1 by 6, 5 by 6. And its value is pi cosec pi by 6. Just putting m is equal to 1. M pi cosec m pi by 6. So putting m is equal to 1, you will get 1 by 6. M is equal to 1 by 6. So pi cosec m pi by 6. Gamma m, gamma 1 minus m is equal to pi cosec m pi. Putting m is equal to 1 by 6, you will get the result. This is equal to this, or is equal to this. Similarly, for this problem, now students, you first take the printout of all the study material and then read it. This is the group 5. Okay. Okay. Thank you. Now, any other question or problem?
No, sir, but this chapter is not on mid-semester, right?
No, not mid semester. Only infinite series without power series.
Okay,
Sir,
sir.
any suggestions for mid-sem?
No suggestion. Only infinite series excluding power series. So, the exam will be held on online mode. So don't
Yes, sir. What's the question pattern, sir? I mean, marking scheme.
marking is actually it depends on the teacher. I was not the subject teacher. Okay, another teacher would set the question, and that depends on that teacher.
Okay, sir.
Actually, attempt 5 questions out of 7. This type of 5 means 5 into 10. Total full marks for the 50 or 30 midterm.
30, sir.
30.
Sir, 30.
30 means 5 into 6. Attempt 5 questions. Each question carries 6 marks. Okay, out of 7. Something like this. Any
So,
other?
sir, there will be step marking, right? 1 plus
Yes,
2
yes,
plus.
yes. Actually, if the problem contains 2 parts, then if it is possible to solve the first part and not second part, then it is then teacher will be given the step marks.
Okay, sir.
Okay. So I am leaving now. Okay.
Okay, sir.
So this is the end of my syllabus. In the next week, I do not take any class.
Sir,
Okay.
when be the next class? This class?
Actually, the course is finished.
Yes.
For my part, course is finished. One is infinite series, power series, and another part is improper integration. Clear?
Okay, sir.
All
Sir,
the
after sir exam, please give us some doubt solving session.
yes. We may take one extra class if you suggest.
Yes, sir. On this integration part especially, sir. If you have any doubt, please clear it, sir.
Through CR, you may proceed now.
Okay, sir.